Today I am going to attempt to show you how to graph y equals the cotangent function and y equal to the tangent function. So similar to us trying to graph the sine, the cosine, the secant, and the cosecant, we will need to account for our transformations. So we really won't just be graphing this y equal cotangent and y equal tangent. We'll be graphing something more to the effect of y equal to a times the cotangent of b times x minus d plus c, and y equal to a times the tangent of b times x minus d plus c. But what's nice about these functions is that we already know how to handle the a value, the b, the c, the d. What we really need to know about is the key points for the cotangent and the tangent. So if you recall, we discussed the key points for the cosine function were 1, 0, -1, 0, and 1, while the key points for the sine function are 0, 1, 0, -1, and 0. Remember, we studied the parent function of cosine to look like this graph over here, and we remember the parent function of the sine looks something like this. Well, the key points for the cotangent function are found in a similar way to finding the key points for the cosine of the sine function. Remember, when we found the key points for the cosine and the sine, we looked at this circle with these points at 1, 0, at 0, 1, at -1, 0, and at 0, -1. We recall that this up here is pi over 2, and we're at pi, and 3 pi over 2, and then 2 pi or 0 at the beginning, depending on where you are, whether you're starting or finishing a complete revolution. So we recall that the cosine of our angle is given as x divided by r, while the sine of our angle is given as y over r. So we said the cosine of pi over 2 was equal to our x value here at pi over 2, which is 0, divided by the radius of this circle, which is 1. So that's how we get the cosine of pi over 2 to equal 0, which is just this key point that's right here. So the way we'll do this for the tangent and the cotangent function is we'll use this same circle that we have up here, but we need to recognize that that a period, and when I say a period, I mean a standard period, for the tangent and cotangent functions is only pi units. So this means that the tangent and the cotangent go through a complete revolution from 0 over here to pi, and then they go through another revolution from pi to 2 pi. So they make, the tangent and the cotangent functions make 2 revolutions in a circle, or two full periods through 1 revolution of a circle. Okay, so we're going to do pretty much the same process that we went through to graph the sine and the cosine. Notice that the tangent of an angle is given as y over x, while the cotangent of our angle is given as x over y. So I'd like to start with the cotangent function, and let's just check it out. The cotangent of 0 will be the x value, which is 1, divided by 0, which is undefined. So when our x value is 0, our cotangent function is undefined. When our x value is pi over 2, we have the cotangent of pi over 2 is equal to, well, the x value is 0 and the y value is 1, and so this will equal 0. When the cotangent is pi radians, we will be back to undefined. We'll have -1 as our x value and 0 in the denominator again, so we're undefined here. So when x is equal to pi, the cotangent function is undefined. This is fantastic and cool and all, but we've only split this period up into 2 pieces, whereas before we were splitting the period up into 4 pieces. So let's add in these 4. Let's divide the period into 4 equal pieces. And so when we do that, we'll see that up here in this circle, we can take our period and divide here and divide here, and we know that this angle is pi over 4. So when our angle is pi over 4, notice that our x value on this circle has to be equal to the y value on this circle. The x value here is square root of 2 over 2, and the y value is also square root of 2 over 2. And then over in the second quadrant, this angle is 3 pi over 4, and our x value will be negative square root of 2 over 2, while the y value is the square root of 2 over 2. So our cotangent function, let's scroll down here to the cotangent function. The cotangent of pi over 4, which is really the angle halfway between 0 and pi over 2, is equal to the square root of 2 over 2 divided by the square root of 2 over 2, which is equal to 1. And the cotangent of 3 pi over 4 is equal to negative square root of 2 over 2 divided by the square root of 2 over 2, which is equal to -1. So the cotangent of 3 pi over 4 is -1. And so from this, we see that our key points for the cotangent function will be a vertical asymptote at the start of our period here. This is a vertical asymptote when our function's undefined. And at the end of the period, we'll also have a vertical asymptote. So we'll go vertical asymptote in the beginning and vertical asymptote in the end. And then we'll have this pi over 2 is in the middle of our period, which is 0. And then when our x value is pi over 4, we have a key point of 1, and then we have a key point of -1 halfway between 0 and the end of the period. So these are the key points for the cotangent function. So let's go ahead and graph y equal to the cotangent of x and see what this thing's going to look like. So y is equal to cotangent of x, well, we see that our a value is 1, our b value is 1, the c value is 0, and the d value is 0, since we have y equal to 1 times the cotangent of x minus 0 plus 0, if you want to stay with our form from the original problem. So here. Now our a value is 1, our b value affects our period. And so remember that we were finding our period when finding the sine and the cosine function by taking 2 pi, which was the standard period, and dividing it by our b value. But here remember that we have the standard period divided by the b value, but in this case the standard period is pi because the tangent goes through pi radians for one period, so this is equal to pi. We'll still find our graphing increment the same way as our period divided by 4, which in this case is pi over 4. And so we'll set up our table. Our x values 0 GI, 1 GI, 2 GI, 3 GI, 4 GI, and we go 0, 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4, which is pi. We're not going to have a phase shift or a vertical shift, so these will be the x values that will go on our graph. And now our y values are just the key points for the cotangent function, which is vertical asymptote, 1, 0, -1, vertical asymptote. So let's see, our graph will look like this. We'll go 1, 2, 3, so that here is our pi units. We'll go -1, -2, -3, and then we'll break our period into 4 pieces. So this is 0, halfway between 0 and pi is pi over 2, and halfway between 0 and pi over 2 is pi over 4, and this is 3 pi over 4. And now we'll draw in our graph from our table over here. So when our x value is 0, we have a vertical asymptote, which is right here. I hope you can see that. When our period ends, we'll also have a vertical asymptote. When x is pi over 4, our graph is, our y value is 1. Our y value is 0 when x is pi over 2, and -1 when x is 3 pi over 4. And then we're just going to connect these dots in between our boundary with a smooth curve. And this is one period of the parent function of the cotangent graph.